Every phone in this stream carries metal, glass, plastic, and risk inside one compact object. The factory begins with collection, because recovery only works when the waste is captured in order. At this scale, transport is not just movement, it is the first layer of safety control. By the time the phones reach the plant, the waste has already become scheduled industrial inventory. The mega factory has to identify the load before it can touch the device. Once inside the gate, every phone is treated as both recoverable material and controlled risk. Unloading is where transport ends and the first controlled separation begins. A phone is not just material. It may still contain private information and stored energy. Identification decides whether a device becomes a repaired product, a spare part source, or raw material. Stored energy is the first hazard the factory must control. Once risky units are isolated, the main line can move faster without ignoring safety. Sorting is the difference between careful recovery and blind destruction. The more precisely the phones are grouped, the cleaner every downstream separation becomes. The first major transformation is simply opening the sealed consumer object.
Once the shell is open, the factory can finally reach the parts that matter.
No serious phone recycling line moves forward until the battery is separated.
After de-energizing, the device becomes easier to dismantle and safer to process. Battery recycling is a separate discipline inside the larger phone factory.
The phone line becomes cleaner once stored energy has left the product path. The screen is both a fragile surface and a recoverable material stream.
After glass separation, the phone starts to break into recognizable industrial fractions.
Some parts are too valuable to destroy before they are inspected. The factory recovers usable modules first, then sends the rest toward raw material separation. The circuit board carries much of the phone's hidden material value.
Once the boards are separated, the factory can treat electronics and housings as different worlds.
The empty shell is not waste. It is a layered mix of metals and polymers.
Separating the casing prevents good metal and plastic from being contaminated downstream.
Shredding begins only after the most sensitive parts have been removed.
Once reduced to fragments, the material can be sorted by physics instead of by shape.
A factory uses magnetism, light, air, and density to pull order from fragments.
Circuit boards are processed in sealed equipment because fine electronic dust must be controlled.
After milling, the board is no longer a part. It becomes a concentrated metal-bearing material.
The valuable metals are recovered inside closed systems, not in open manual handling. The goal is to separate value while keeping chemistry, dust, and residue under control. The copper inside millions of phones becomes visible only after many separations.
A small device stream can become heavy metal inventory when the factory operates at scale.
The phone body becomes metal inventory once coatings, screws, and plastics are removed. structural metals are recovered in bulk, even when each original frame was small.
Plastic recovery depends on separation before melting, because mixed polymers lose value quickly.
The plastic parts of old phones can re-enter manufacturing only when they become consistent again.
Phone glass is thin, layered, and difficult, so the factory handles it as a dedicated stream.
When glass is cleaned and sized, it stops being broken waste and becomes industrial cullet.
Recycling is not finished until the recovered material is measured. Certification turns recovered fractions into products that manufacturers can trust. Packaging preserves the identity that the factory spent the entire line creating.
At this point, old phones no longer exist. Only certified material streams remain.
Dispatch closes the factory loop and opens the next industrial loop.